DARPA plans a program to build massive structures in orbit with paradigm-shifting technology. I guess this is the beginning of Dyson spheres. The Defense Advanced Research Projects Agency, DARPA, of the US is making a financial significant step towards overcoming the challenge of assembling large-scale structures in orbit by testing new in-space manufacturing capabilities. Despite significant advancement in spacecraft design and other related space technologies, building large-scale orbital structures has long represented a challenge due to the limitations imposed by the size and weight of cargo rockets can carry with them into orbit. To overcome this, DARPA recently announced it's shifting the final phase of its novel orbital moon manufacturing materials and mass-efficient design NOM-4D program from laboratory experiments to small-scale orbital demonstrations. NOM-4D, pronounced NOMAD, aims to test new materials DARPA has developed with the agency, says could significantly enhance the in-space assembly process in the coming years. Rethinking large-scale space construction. Launched in 2022, the NOMAD program was established with one primary goal: overcoming traditional limitations imposed against space infrastructure. And to accomplish this, DARPA team behind the program envisioned to deliver lightweight raw materials to space where they would be assembled in orbit. Traditional approaches have relied mainly on the pre-assembly of space structures on Earth, which are then delivered to orbit where expansion or limited additional construction may occur. Overcoming such limited past approaches, NOMAD seeks to introduce a new paradigm in space infrastructure that will enable the assembly of much larger orbital structures, which are also designed to be more mass efficient than those carried to space aboard rockets. DARPA says the NOMAD program is now on the path towards making this futuristic vision of orbital infrastructure a nearer term reliability, thanks to rapid technical progress that in earlier project phases were not taking place. Following successful experimentation on the ground, the agency green-lighted 2 key orbital tests to evaluate whether this approach can work beyond the lab. According to NOMAD program manager Andrew Detter, a pair of university-led research teams from California Institute of Technology, Caltech, and the University of Illinois Urbana-Champaign will guide the third phase of the program following significant advancements each made during the prior phase of the development. Originally, phase 3 was going to be about making things more precisely in the lab than we did in phase 2, Detter said, adding that after some thought, the NOMAD team ultimately thought there would be more impact if we took the capabilities we have now and actually go demonstrate them in space to show that it can be done. But this is much easier said than done. To take the work the NOMAD team accomplished in the lab, carry it out in orbit. Pushing the performers to do a demo in space means that they can't just sweep challenges under the rug like they could in the lab, Detter said. You better figure out how it's going to survive in the space environment. Mass efficiency in space. The Caltech team primary focus will involve developing mass efficiency designs for in-space manufacturing, partnering with Momentus Inc. The technology is expected to launch aboard the Momentus Vigoride orbital service vehicle as early as February of this year, carried into space as part of SpaceX Falcon 9 Transporter 16 mission. And during the orbital experiment, a 1.4 meter, that's about half a yard diameter circular truss will be assembled, a process that aims to simulate the structural framework of a space antenna. A key objective of the test will be to help the NOMAD team gauge whether lightweight composite fiber longerons could be arranged into large-scale structures without any human hands present. Meanwhile, the University of Illinois Urbana-Champaign, UIUC team, in collaboration with Voyager Space, plans to test a high-precision in-space composition forming process on board NASA's commercial resupply mission NG-24 in April 2026. The UIUC team will use special frontal polymerization process to combine hardened sleeves composed of carbon fiber with liquid monomers in space without requiring any significant heat source. DARPA emphasizes this technology will also play a crucial role in large-scale space construction in the future. This frontal polymerization method allows structures to harden progressively, enabling potentially unlimited expansion only restricted by the available feedstock, DARPA says. And finally, an additional research team based at the University of Florida will conduct tests on the ground to help refine techniques for bending sheet metal using lasers. This experimentation stage will be conducted in collaboration with engineers at NASA's Marshall Space Flight Center. It's hoped to offer additional resources and potential manufacturing methods for space-based construction. If all goes according to plan, the NOMAD team's innovations could potentially revolutionize space infrastructure in the decades ahead. In addition to larger, more complex orbital laboratories that can house astronauts for a range of specific missions, the DARPA team's technologies could also help facilitate construction of large radio antennas for communication systems, as well as solar arrays for power generation and refueling stations for future spacecraft. Another longer-term objective the team has in mind involves 100-meter wide, that's 300-foot space-based antennas, which could dramatically enhance situational awareness in the cislunar region between Earth and the Moon, where communication and other operation factors can become challenging, especially during crewed lunar exploration missions. DARPA expressed confidence that the NOMAD 4 team's vision could improve all these areas while helping to facilitate advanced new capabilities that will further humankind's exploration beyond the Moon. And DARPA said this could pave the way for a future where massive space structures support national security, commercial ventures, and deep space exploration. And this is by Mika Hanks on the debrief. Please leave your comments, and thank you for your support. My Patreon account, the daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.